So here we're starting off in 1.1 with adding real numbers and taking a look at the types of numbers here. First thing we're looking at is whole numbers. Whole numbers start with the 0, 1, 2, 3, and so on. Whole numbers do not have decimal portions to it. So whole numbers only are, like it basically says, a whole number, no decimals. Now integers include whole numbers. So integers uh, include the whole numbers, and it include negative numbers. So -1, uh, you know, -1, 2, 3, and so on. So it includes the negative numbers and the whole numbers portion to it. So that's what makes it an integer by adding in the negative numbers to it. But again, no decimals with integers. Rational numbers can be terminating or have repeating decimals. So with a rational number, basically it's a fraction. So a rational number can be terminating or have repeating decimals. So that's the important thing to remember about it. So some examples we have is 1/4. Well, 1/4 is a terminating decimal because a 1/4 is equal to 20.25, and when you calculate that, uh, but it terminates at the 5, meaning that it stops it. The numbers do not continue on and on. Another example of a rational number is 1/3. So 1/3 is a non-terminating decimal. And what we mean by that is that it continues on and on. And it doesn't necessarily have to continue in a repeating fashion like it does here, but the idea is that it can be either a terminating decimal or a non-terminating a decimal number, meaning that decimal number just continues on and on. Irrational numbers, on the other hand, uh, they are non-terminating decimals. So, like when we looked at 1/3. But the only thing is that irrational numbers cannot repeat the decimal number. So when we looked at 1/3, we see that 3 is repeating, and it will continue to repeat through, if you could, as far as we could see, indefinitely. So that's the difference here, is that 1/3 cannot be an irrational number because it repeats that decimal number of 3, 3, 3, and so on. It continues on. So the best way to determine, if you have a rational number or irrational number, is to divide the number out. So that way, you know whether you're dealing with either divide the number out or calculate the number, uh, and see what type of decimal you have. Um, Irrational numbers do not stop, and the decimal number do not stop, but it cannot be repeating. And real numbers are all numbers. So all types of numbers are real numbers. When we look at example 1 here, we ask what type of number is the square root of 7? Well, if we calculate that through a calculator, we'll find out that it is 2.645751, and that continues on. And we can see that there's no pattern of repeating decimals. So therefore, this is an irrational number. If we go back and look at the definition of irrational number, it is non-terminating, meaning that this number, the decimal numbers will continue on and on. And not only that, it is non-repeating. In other words, the decimals do not repeat. Because we have 6, 4, 5, 7, 5, 1, and if you look in your calculator after making that square root of 7 calculation, you'll see that the numbers do not repeat in some type of pattern. So there's no pattern of repeating decimals. That's what makes it irrational. In example 2, we're looking at the type of again, we're looking at what type of real number, what type of number this is, -5, 6. Again, when we do the calculation to determine a decimal number, we'll see that this is a -0.8333, and that 3 will continue on and on. So again, going back to the definitions of what, looking at what type of number this is, either going to be rational or irrational, so we have to make sure that you understand that. Yeah, and irrational numbers cannot have repeating decimals, so it cannot be irrational, so therefore it's rational and real. In example 3, we want to know what type of number this is. And the number is 6.434343. As you can see already, that 43 is repeating as a repeating decimal. Irrational numbers cannot have repeating decimals. So therefore this cannot be irrational, and it is rational, a rational number. And it's real. All numbers are real numbers. Now here we're looking at number line. The middle point is our 0 point or starting point. To the right of the 0 on the number line are your positive numbers, starting with 1, 2, 3, and so on. To the left of that 0 is your negative numbers, -1, -2, and -3, and so on. If we look at the next number line here, that is a number line where we again see our 0 point in the middle of the graph, and we can think of that as like sea level. So sea level is where the water and generally the ground is at. So if we go below sea level, we go in the negative direction, so deeper into the water. And if we're above zero, we're up above, heading towards the sky. Let's say that we have a diver at around this point right here. That point is about -3. So the diver is at -3 uh, underwater. And, of course, if the diver wanted to be back to sea level, you'll have to go up, a little past the 0 point. So in this example here, a diver is 3 feet below sea level, at that point. That's how we would describe it to someone. The diver is 3 feet below sea level. And we can think of that as the absolute value of -3, because in general we won't say that a diver is -3 feet. We would probably explain it to someone as that they're 3 feet below below sea level. And that brings us back to absolute value. The absolute value of a number is the positive value of that number or variable. So, for example, when we look at um, the absolute value of -5, that these bars represent absolute value. So when you see those bars, that's how you have to think of it. And we're taking the absolute value of whatever's on the inside of it before you do anything else with it. So the absolute value of -5 is 5, the positive value of the number. The absolute value of 3.25 is 3.25. So again, a positive value of whatever's inside of that absolute value. Now, if you have an absolute value with the negative number on the inside and a negative outside of the absolute value, then one thing you want to keep in mind is that you cannot distribute that negative to you cannot distribute it. You have to take the absolute value first, and then so you take the absolute value first, which will give you a positive 2.6. But then you have to come back and drop this negative that was on the outside of it back in front of your number. So the absolute value of negative absolute value -2.6 is -2.6. That negative comes from the negative that's on the outside of that uh, absolute value. So now we want to take a look at adding numbers with the same sign. When we add numbers with the same sign, we add the numbers together and keep the sign. So, generally we're familiar with adding positive numbers. So like 3.3 plus 5, that gives us a positive 8. So a positive 8, we just make it into 8. But if we're adding numbers with adding negative numbers rather, if all of the numbers are negative, we would just add the numbers as normal and keep the negative sign in the answer. So for example, if we're taking negative 5 plus a negative 6, both of them are negative, so we add the two numbers together as normal, which will give us 11, and then keep the negative sign with it. And example 2 here, you have a negative bank balance of $21. So in other words, negative 21. You go to the bank, you go to the store and make a purchase for $33 with your ATM card. And what we would want to know is, what is your new balance? Well, we started out with negative 22. So we take that negative 22 and we add it to what was just purchased, because the purchase is coming out of your bank account. So that's going to make it a negative 33. So negative 21 plus negative 33. Both the numbers are negative. So our result with adding the two numbers together is 54, and we put the negative back out with it. Here we want to add the number that we see here. So they both are fractions. So negative 4 over 5 plus negative 2/15. So both of them are negative. That means that when we add them together, we're going to keep the negative sign. We have to find the LCD for when we're adding or subtracting fractions. So here 5 divides evenly into 15. So 15 is your LCD. We just have to make the first fraction have the denominator of 15 by multiplying both the numerator and denominator by 3. Once we do that, we'll wind up with negative 12 over 15 for that fraction. And now we can add it since they both have the same denominator. So 15 is going to remain our denominator. We add the tops together and then bring out the negative sign. So negative 12 plus negative 2 gives us negative 14. That gives us negative 14 over 15.